Algebra 1, Section 6.4, standard form. I'm sure I'll explain this in class as well, but just a quick explanation here. I do teach these out of order. 6.2 is slope-intercept form. 6.3 is some application of slope-intercept form, like some real-life examples. 6.4 is standard form, and 6.5 is point-slope form. When teaching it the traditional route, teaching it in that order, 6.2, 6.3, 6.4, 6.5, what tends to happen is students feel like slope-intercept form is home base, it's the most comfortable one, and it's the one that they try to do everything out of. I'm trying to break you of that. I want you to see the value in each of these three forms, and I feel like by doing standard form first and point slope first second, I have a better chance of convincing you of that. Ultimately, it's up to you. It's not up to me to get you to realize that. I've expressed the goal to you. I want you to see this in standard form. It'll help you on the quiz and the test to be able to graph things out of standard form as is and not have to switch everything over to point slope form. So that's the route we're going to take. This is what I've done for years. It's worked very well, but I have to have buy-in from students. So we're going to talk about standard form today. In this video, we'll talk about point slope in the next video, and then we'll go back in the book and talk about slope-intercept form after we've discussed the other two. There isn't one that's more important than the other. They're all three important. Okay, so today we're talking about standard form. Notice that it says with integers. That is because A, B, and C need to be integers. Okay, no fractions or decimals. Okay, someday you will have a teacher that will require this integer to also be positive. I do not require that. In Algebra 1, I'm more interested in you getting integers here. So again, integer is just 0, 1, 2, 3, 4, 5, etc., or the negatives of those numbers. So if you have a negative number here and it's negative 3x plus 4y equals 27, great. That would be standard form. Let me write that down. Negative 3y, I can't remember what I just said, negative 3x plus 4y equals 27 is standard form. Just the same, positive 3x minus 4y equals negative 27. In my book is standard form. If you have a different, if you have a teacher who tells you something different next year and requires this, well, then you're going to have to do what that teacher says. But the point here is that these numbers are integers. These numbers here are integers. Whether they're positive or negative, they cannot be fraction or decimal. Okay? So with that, let's do a few examples. It says find the x and y intercepts of 2x plus 5y equals 6. This is in standard form. Notice the position. X comes first, y comes second, then it equals, then the constant. This is in standard form. And what you must know, and really the biggest valuable item of standard form, is the fact that you can find intercepts easily by plugging 0 in for the other variable. So for example, if I wanted to find the x-intercept, what I would do is plug 0 in for y. When I want to find the y-intercept, what I do is I plug 0 in for x. Okay? Now, as I show you the work here, let me show you their work. They're going to do a lot of work. I don't think that's really necessary. I think you can probably get away with a lot less work if you would just consider the fact that when you plug 0 in for y, that this whole thing right here is going to become 0, right? So this is like saying 2x plus 0 equals 6. That's like saying 2x equals 6. 2x plus 0 equals 6. So we're solving, as we plug 0 in for y, we're solving 2x equals 6. You probably don't even need to write that down. You can if you want. I don't require it. If you can envision this being 0, you probably can then just visualize the fact that you're going to divide both sides by 2, and you're going to get 3. So there's the x-intercept. It's at 3, 0. If instead I want to find the y-intercept, what you do is you plug 0 in for x. That's what you see here, this ordered pair. I'm plugging 0 in for x, and this whole thing goes away. And now you're left with just 5y equals 6. And if you divide both sides by 5, you'll get the fraction 6/5, or 1 1/5, or 1.2. All of those are okay. These are the two intercepts, though. Now, just to be really clear, these are the ordered pairs. In my world, the x-intercept is a number. So the x-intercept is really 3. To say x-intercept is to imply that it crosses the x-axis here. So we know the y value is going to be 0. So again, in my world, and for my requirements for you, the x-intercept is the number 3. The y-intercept is the number 6/5. Okay? Now, you're never wrong to include the ordered pair. Just don't get it backwards. Okay, if the ordered pair, if the x-intercept is 3, and you should write 3, 0, well, first of all, you should write 3, but if you decide to write the ordered pair and you say 0, 3, well, that's wrong. And I can't give you full credit for something that's wrong. So if you're going to give the ordered pair, you better make sure it's right. Don't get them transposed. So then there's this graph, 3x plus 5y equals 15. Again, we want to use standard form as it is and plug 0 in for x. This will be really easy. You plug 0 in for x, you'll get a y value. You plug 0 in for y, you'll get an x value. I plug 0 in for x, this is gone. Divide both sides by 5, you'll get 3. I plug 0 in for y, this part is gone. Divide both sides by 3, you'll get 5. Now, why is that so valuable? Well, because with very little work, what I think is a lot less work than switching things over to slope-intercept form, as I'm trying to discourage you from ever doing, is you just figured out those values. Again, this work is not necessary, right? You show some work if you want to, but this is not necessary, and I just demonstrated for you that you really don't need to show any work. But the point is that now you can plot the point 0, 3 as they have, and 5, 0 as they have, and then you can draw the line that passes through those 2 points. So you're going to need some graph paper for this lesson. I'll probably give it to you. You might want to remind me. I'm recording this on October 8th, and I don't think we'll be into this chapter for like a month or more from now. Okay, so next example. Graph y equals 4. In the previous lesson, we talked about vertical and horizontal lines. Y equals 4 would be the horizontal line. I wish they would just give me the graph here, but so y equals 4. Why is that a horizontal line? Well, because the y value is always 4. So here's the point 0, 4. Here's the point 1, 4. Here's the point 2, 4. Here's the point negative 3, 4. The common theme there is the y value is 4. A lot of times people will look at this and say, okay, there is no x. Well, it's not that there isn't an x. It's just that x isn't evident in this equation. In fact, this isn't standard form. It's like saying 0x plus 1y equals 4. This is why this is in this section, because this is in standard form. And the thing is you can let x be whatever you want. It's not that x doesn't exist, like x doesn't have any values. No, x has all of the values, all real numbers. And regardless of what you let x be, y is still 4. Okay, so let x be negative 1, y is 4. Let x be negative 2, y is 4. Let x be positive 1,000,000, y is 4. You know, it's way up 1,000,000 units this way. Okay, so when we collect all of those points then, where y is 4, it actually makes this horizontal line. Now, if you didn't like that explanation, maybe you'll prefer this one instead. Y equals 4. Go on the y-axis to 4. 1, 2, 3, 4, and then just draw the line that's perpendicular to the axis. Okay. The first explanation was more conceptual. The second explanation is more like the rule. Count out on the y-axis, make the line that's perpendicular to it. That's the line y equals 4. So where do you think x equals negative 3 is? It's going to be a vertical line where x is equal to negative 3. So here you go. Again, here's the point negative 3, 0. The x value is negative 3. Here's negative 3, 1, negative 3, 2, negative 3, 4, negative 3, negative 4. Negative 3, negative 500 would be down this way. The common theme is x equals negative 3. Or again, if you just like the rule and don't really like the explanation there, just count yourself out on the x-axis to this number. X-axis to this number, negative 3, and draw the line that's perpendicular to the axis. All vertical lines are of the form x equals a number. In this case, you have x equals negative 3, so it's vertical on the x scale, on the x-axis where the scale is at negative 3. X equals negative 3. We will practice this kind of problem at a later date. So then we're on to this last problem, which says write an equation in standard form to find the number of hours you would need to work at a job to make a total, at each job to make a total of $130. You mow lawns for $12 an hour. You deliver newspapers for $5 an hour. Now they're defining the variables for us here, so we will use x and y. You could use different variables if they didn't give you any direction. M for mowing and D for delivering, or L for lawn and N for newspaper, whatever. But they have said use X for lawn mowing and Y for newspaper, delivering newspapers. So we'll do the same thing. You make $12 per hour mowing lawns. That would be 12X. You work 1 hour mowing lawns, you're going to make $12. You work 2, that's 2 times 12, you're going to make $24. add that to the amount of time and the hours, the amount of time times the hours that you work delivering papers, and you're going to make $5 an hour delivering papers. You need to make 130. So there's an equation in standard form that models this situation. Okay. Now here's the thing, and it didn't ask us to do this. It just said write an equation. But think about this now. From the previous examples, if we plugged 0 in for x, this is now 0, and you could divide both sides by 5, and you'd get 26, which means that if you did entirely newspaper delivery, you'd have to work 26 hours to make your money. Whereas if you plugged in a 0 for y, meaning you delivered papers not at all, and then you divided both sides by 12, you'd get a little bit over 10, something between 10 and 11. That means you need to work, almost 11 hours to make your money mowing lawns. And then there's a whole bunch of combinations in between, which is probably the most realistic of the problems, right? You could work, well, let me think, 5 hours, just trying to pick nice numbers, 5 hours mowing lawns, that would be $60. Then you'd have to make another 70 doing this, so 14. You could mow lawns for 5 hours, deliver papers for 14, and that would give you your $130. All right, thanks for watching.